So we're going to look at the energy content in food. As well as some other nutritional values. We're first going to define a nutrient. This is a chemical substance in food. That provides energy and raw materials required by chemical reactions. So really, we're eating for two reasons. We're eating because we need to create products which we don't currently have, so we can get those raw materials through food, and then we have to process those. So we need those reactants, and we need a lot of these conversions are from lower energy ingredients to higher energy products, and so that requires energy. It's uphill, and so we need that energy as well. So really, food comes down to we look at energy or raw materials, and so we're going to break this up. We're looking at these nutrients. So there's 5 classes of nutrients. So 5 classes of nutrients. And we'll be looking at both kind of what building blocks are providing building materials, and we'll say plus H2O. We need H2O, but it's not one of the 5. And so we're going to look at kind of energy, content, or raw materials. So one is carbohydrates. But really, a carbohydrate is just a bunch of simple sugars. So we can digest that down into simple sugars. So we'll talk about things like starches, or actually just strings of sugars. A simple sugar being it's not an N monosaccharide. Mono, give ourselves some room here. It's one word, monosaccharide. The next one is fats. Really, fats and oils, again, like the only difference is fats are solid, room temperature, oils are not, and we'll get into that in a sec. And we can digest fats down into kind of more simple building blocks, which is glycerol, kind of went over that before, and fatty acids. So when we were looking at biodiesel, that reaction, we saw that. The next one we're going to look at is proteins. So proteins, if we digest those down, the building blocks that we get out are amino acids. So the first 3 are more complex structures that once we eat these, our body breaks them down to the building blocks that we're going to use to build up other things. So simple sugars go anything from sugar backbones to DNA to many, many different structures. Again, glycerols, fatty acids can be used for lots of things, and amino acids can take proteins and make new proteins that we need, along with many other things. We have 2 others that are not broken down, but they are still essential for our functions. So these are just straight up raw materials. So we have vitamins and we have minerals. So these are the 5 classes of nutrients. And so we're going to first look at a couple things about them, and then we're going to break down each one of these in more detail. So let's first look at a big picture of what's going on. So we have first, what are we eating? Our diet side. So we have energy yielding nutrients. So we want to get energy out, energy yielding nutrients. So, let's not do that quite yet. So we'll just do an underline there. So we have the three that we have, or the first three we talked about. So carbohydrates, fats, and proteins. Now, they don't yield the same energy, and we'll get to that in a sec, but they all have energy content, so we can break these down into two components. So we can break down and we can release energy. So we call this catabolism. And so we're going to get two things. The first thing is we're going to get chemical energy, so energy that came from chemical process. But we're also going to get energy poor products, or end products. Energy poor end products. So we can't really do much else with these. They are just who they are. That includes water, which is still very useful, CO2 and NH3. And really what energy poor means, like I can use another word for that, and that's just like super stable. So remember that you can get energy from unstable reactants that you can convert to stable products and take that extra energy you lost to do something. So energy poor really means stable, so it's not actually a bad thing. So we have chemical energy, and so that can be used to, so first we have kind of our raw ingredients. We can call these precursor molecules. So this is where we are going to have building blocks, and that's going to be the things that we digested out. So we got simple sugars. We have amino acids. We have fatty acids. We have nitrogen-containing compounds. This is very general, but and so we take these precursor molecules with the energy, and we're going to make cellular macromolecules, or basically big things. So take small things, build them up. Cellular macromolecules, that's just really big molecules. And those are going to be proteins from amino acids, polysaccharides from monosaccharides or simple sugars. So it's kind of like we ate proteins and polysaccharides, and then we digested them and then rebuilt out something. It's kind of like a Lego set where you build something, you take it apart, and you rebuild it. My son does it all the time. And nucleic acids. And we'll make this like this. Make the box this way. Move it up a little bit. Okay. So anyway, so we're using energy, taking these cellular macromolecules and using them to rebuild using some precursor you already had. And let me finish this up. So we have our diet is yielding this. These are what we call waste products. We have over here, these are products of the digestions. And these are essential biomolecules. These are really why we're eating stuff. We need these to function. Okay, so we got a lot going on there, but we can kind of see the cycle. If we talk about energy content, so energy content of these different energy yielding compounds. We have three. We have fats, we have carbohydrates, and we have proteins. Now we know that all of these can have some type of energy. So we're going to use kilocalories. So because it's America, we can. So this is 9 kilocalories per gram. So for every 1 gram of fat, we could, on average, have 9 kilocalories. For a carbohydrate, for 1 gram, we have 4 kilocalories. And for proteins, we also have 4 kilocalories per gram. So you can see that a fat has twice as much, more than twice as much stored energy than carbohydrate or protein. So that's actually really good. So if you need a lot of energy, you want to eat fats. Turns out if you eat too much fat, your body doesn't need as much of that, and we're going to store it for later, which is not great. So we're going to we're not going to really get into the right now the how we can get energy from these, but we can talk about each of the different essential nutrients. So we'll start off